Hello everyone, welcome back to chemistry class. In the previous lecture, I talked about various processes of interconversion of states like vaporization, fusion, that is melting, then freezing, condensation, sublimation. In today's class, I am going to talk about evaporation. This is the term that you have heard about it and you have studied from last many years. This lecture, or in this class, we are going to study in detail the process of evaporation. So more science behind it we are going to study. So let's start. So what is the definition of evaporation? So the change of a liquid into vapor at any temperature below its boiling point. Okay. So when a liquid changing into vapor, that process is called as evaporation, and you know it is important process for our nature. Okay, now this evaporation, it depends on many factors. Okay, so before going to that factor, let's see what happens when water is evaporated, or how water or any liquid is evaporated. So here is a container, here is water, and this circle, they are particles. Now the particles which are on the surface, they are bound from only one side with, if say this is the surface, these particles, they are bound only from this side to the other particles, and on one side they are free, right? So it is easy for them to gain energy and to move fast as compared to the particles which are here, which are bounded by particles from all the sides, and similarly for the bottom one. Okay, the particles which are present on the surface, they gain energy because they have lower force of attraction. They gain energy faster as compared to this one. And how they gain energy? They gain energy from the environment. Okay, now once they gain energy, they are able to break the bond and they are free to become vapor. And in this way, liquids get evaporated. Now, for the particles over here, they are also trying, they are moving, but they don't have enough energy and they are pulled back. Similarly, at the bottom, no energy, so they will remain in the liquid state. So, evaporation is a surface phenomenon. Why it is called surface phenomenon? Because particles get started converting into vapors from surface only. Whereas if you say boiling I told you is a bulk phenomenon. Okay, bulk phenomena means once the whole liquid will attain a certain temperature, then only boiling will start. More about the difference between boiling and evaporation, we will see in next few minutes. So, hope you understand how particles on the surface are converting into vapors. Now, the rate of evaporation, high, low, it will increase or decrease. It depends on certain factors. So, certain factors like surface area. If this I will try to explain you by an example, and then you can decide whether increase in surface area will increase the rate of evaporation or decrease. Okay. So what? So if let's say if you take a hot glass of milk, you have hot milk. Now you pour that milk in two containers. One container which is having a very small opening. Let's say like this glass. Okay. And so you add half of your hot milk over here and half of the hot milk on this saucer. Okay. So what do you think? Which one is going to cool faster? Obviously this one, where the container is having more surface area. Okay. So this you may have observed in your daily life. So for any hot thing to drink fast, you put that in a plate and then you drink so that it cools down faster. Why? Because there is increase in surface area, increases the evaporation rate. And as I told you, when this liquid it changes into vapors, it takes heat from the surrounding. That means it will cool the temperature of that liquid. So the vapors, this liquid it will get evaporate. In turn, it is taking heat from this liquid. So it will cool down this liquid a little bit. So in this container, you will have faster cooling as compared to the container whose surface area is less. So increase in surface area will increase the rate of evaporation, and it will make that thing cooling faster. It will make cooling faster. So instead of the saucer, if you take a big plate, then evaporation rate will be more high, and you can cool it down in a minute. Not temperature. So what do you think? If temperature is raised, what will happen to rate of evaporation? It's obviously need not to think much about it. Just see your daily things. When you increase the temperature, you will see more vapors coming out of a liquid. Okay. So if a container with a liquid is on a gas, if you increase that flame, obviously increasing the flame means you are giving more heat energy, more temperature. That means it is going to convert into more vapors. That means rate of evaporation will increase. So increase in temperature will increase rate of evaporation. Next, coming to humidity. What is humidity? Humidity is, yes, presence of water vapors in the environment, right? Now, already water vapors is here. This rate of evaporation, let me tell you one thing about this humidity. Nowadays, you can experience this much more as compared to other. Like in summer season, presence of water vapor is less. So though it is hot, but there is nothing like sweating. But nowadays, humidity is high in environment, and you feel like sweating everywhere. Like, okay. Now, you have noticed one thing. The coolers that you use at home for cooling, okay, they work better in during peak summer times as compared to this humid environment. Like when there is much more water vapor in the environment. Okay, you may have heard कि अब तो कूलर काम ही नहीं कर रहा है इस मौसम में. Why? Because the cooler is also based on this process of evaporation. Okay, water, it gets evaporated, it takes heat away from the liquid and cools down. Now, during summer, this rate of evaporation is high, so the cooling from coolers that you get is also very good. Now, when water vapor is already present, okay, temperature is now low, what will happen is rate of evaporation will decrease now. Okay, when rate of evaporation will decrease, obviously this cooler is not going to give you that much of cool air. So during humid days, like when water vapor content is high in environment, a cooler is not going to work effectively. And this is not in the case of AC, because AC works on very different principles. Okay, so if there is increase in humidity, because if there is already water vapor in the environment, the rate of evaporation will decrease. And the next point is wind speed. With increase in wind speed, it will take particles more fast away from that area, and as particles they are moving, the rate of evaporation will also increase. They will get more fresh area to evaporate. And when you increase wind speed, particle movement will increase, and it will also increase rate of evaporation. So mainly there are four factors that define or that affect evaporation is surface area, temperature, humidity, and wind speed. I hope now you are able to answer many simple observations of your daily life. So how desert cooler works, why didn't work during humid days, then when you sprinkle, this we used to do earlier, you sprinkle water on rooftops and it cools it down. So that also you can explain on basis of this evaporation. Then the wet clothes, they get dried. That also you can explain by this evaporation. The next thing is you should wear cotton clothes during summer. Why? Why it is recommended? Because cotton, it absorbs water, or you can say sweat faster. Right? When it absorbs, what it will do? After absorption, now this will be evaporation. Now, when this evaporation takes place, what it will do? It will lower the temperature of your body. Same thing with sweating. You sweat more during summer. Why? To keep your body cool. When you sweat more, then there's higher rate of evaporation from your body, and when it changes to vapor, it will cool down your body. Okay, so should wear cotton clothes during summer. This is helping in keeping your body cool. Now, what is the difference between boiling and evaporation? Boiling is a bulk phenomenon. Now, what is meaning of bulk phenomena? So, let's say you have two containers over here with water. Okay. Boiling, it will start only when a liquid attains certain temperature. For example, for water, boiling temperature is 100 degrees centigrade. So particles over here, the whole liquid particles, when they will get this temperature, then they will start boiling. That point we will call boiling. And you can see bubbles during boiling. Okay. Before boiling, when heat is applied to the system, at that particular time it is not boiling. You can see vapor, but that process is evaporation, not boiling. Okay. So when you are heating these two, when initially you see vapors, this is nothing but evaporation. Boiling starts only when the liquid attains a particular temperature or fixed temperature, whereas evaporation, it can start at any temperature. As soon as the surface particle, they get enough energy, they will start evaporating. Okay. So, and it starts from surface only, no matter what the particles here are doing. But evaporation, but boiling, it starts only when the whole liquid particles over here in the bottom, will gain enough energy to break the bond, and then they'll boil. Okay. So it is bulk phenomena, surface phenomena. Evaporation takes place at any temperature, whereas boiling is fixed. It has a fixed temperature. After that only it will start. Okay. And in boiling, there is nothing like cooling of a liquid. Whereas evaporation, it lowers the temperature. In boiling, there is nothing like that. Okay. And yes, for boiling, you need external source of energy. So in most of the cases, you need external source of energy. Whereas in evaporation, no. Simple sun heat or room temperature is enough to convert it into vapor. So this is the main difference between boiling and evaporation. And vaporization, what is vaporization? It is phase change of liquid to gas, right? So you can call like vaporization is of two types, boiling and evaporation. Okay. So hope the difference is clear to you. And this is this much for your first chapter. And I will try to give you, not try, in the next lecture, will give you question and answers of notes of this chapter, and question and answers. I will try to give question and answers.